the temperature, and I'm telling you it's 273. So we're going to make this V1, and we're going to make that T1. All right? And what is this? That's a volume. We're going to make it V2, and we're looking for what?
T2.
T2. Okay? So V1 is 3.84 liters. T1 is 273 kelvins. V2 was that 638 milliliters. Do I remember that right? Yep, 638 milliliters, and we're looking for T2. Now, temperature is already in Kelvin, so I don't have to change it. So I need to make sure my units match. Do my units match?
No.
You can either make them liters or you can make them milliliters. It doesn't matter which one you do. All right, so if we go to liters, we're going to do milliliters, liters. Which one's bigger?
Liters.
This is the one I told you to memorize. You don't have to, but quite frankly, I'd get tired of doing this all the time. King Henry died by drinking chocolate milk. 1, 2, 3 spaces. I would learn this is 1,000 because you're going to use it a lot. All right, so you're going to get 0.638 liters.
Correct.
All right, so from there, V1 over T1 equals V2 over T2. V1 is 3.84. T1 is 273 equals 0.638 over T2.
Okay, start over. I need to see it.
Doesn't matter what can you convert it to.
Nope, it does not. You could just easily done milliliters. I did liters because that's the first one I heard when Nakia yelled it out. But if you did milliliters, it would still give you the exact same answer. All right, so when I cross multiply, I get 3.84 T2 and 273 times 0.638. Divide by 3.84 on this side. Divide by 3.84 on this side. Can somebody tell me what T2 was equal to? What?
45.4.
45.4? And that's in kelvins?
Yes.
Yes.
Okay? Now, from there, if the question said Celsius, what did I say?
You convert it back.
You convert it back. All I said was what was the new temperature?
So you can leave it.
I would leave it. I would not change it back. That would be my answer.
Girl, me out.
Okay? Any questions? Except you can't see that decimal.
Does it have to be 45.4? 45.
45 is fine. I told you I would not take off for significant digits at this point, providing you're close. All right, number 2. All right, I'm asking for a partial pressure. What law did we learn about that have partial pressure in it? Dalton's. So you should be using Dalton's law of partial pressures. So how many gases did I give you in this?
3.
I gave you 3. So we're going to use PT
Gotta remember
equals
that too.
P. It's on the reference sheet.
Oh.
All right, the only catch to this was what?
That'd be equal.
They all had to be the same unit. So I've got, has a total pressure of this, right?
Yes.
So 7.56 ATMs has to equal. Neon has 8.50 torr plus 156.8 kPa plus whatever the partial pressure of neon is. Sorry, xenon. So what's my glitch here?
They're not all the same.
They're not all the same. So they got to be the same. So this
ATM.
has to be changed. I'm going to change it to ATMs just because that's usually what I change it to because we need it in that for today's lesson. So 850 divided by 760.
What'd you get? 850.
850 torr.
Go ahead.
Torr. ATM. ATM gets a 1. Torr gets a 760. So 850 divides 760 gives me 1.11. All right. Plus 156.8 divided by what? 101.325. 1.54. Plus the partial pressure of xenon is equal to 7.56. So what am I doing to get xenon? Add them and then do what? Subtract it. So 7.56 minus I have 4.91.
Yes.
Now, that's in atmospheres. Anybody have it in a different unit? I'll be glad to tell you the answer if you put it in ATM or KPA. Torr or KPA. Anybody else do it in Torr or KPA?
The only one we need to memorize is Pascal's.
It's Pascal's, PA.
What'd you get for the answer?
0.1325 times 10 to the 5th. So what now?
What's the answer?
4.91. Questions?
Bill Nye time.
Yeah, do we have, yeah, most definitely got it.
No.
Stop it. Why would you do that? Why would
Because
you?
I didn't put Bill Nye up
I'm
there.
gonna cry.
Numbnuts up here on the front row did.
And race quiz.
Yes.
Yes. Annabelle erased quiz and wrote Bill Nye. I never put Bill Nye there.
I thought
you
it would
were
be nice. And you follow the agenda.
Annabelle put Bill Nye there, not Miss Wall. All right. Do I ever look at Bill Nye?
Can we
No.
please look at Bill
All
Nye?
right. Question number, what is first? 1?
Yes.
Number 1.
Herman,
No.
I want to look like Cheyenne.
Oh,
Right.
Cheyenne said to get you.
Cheyenne said you trying to play her because her buttons don't look like that.
I can't do mine like that. No.
Yeah, the Cheyennes are much cuter.
That's because your hair is much thinner and nappier. Just give me a hairband and I'll
All right. She looks like she's got a miniature version of Diavion
She
going
looks
on.
like a crackhead.
Who does?
Annabelle.
Thank God. I thought you were saying Cheyennes did. I was like,
No.
hers look really neat.
I always say Annabelle. I don't have a mirror. I ain't trying here.
I'm not sure a mirror's going to fix that. All right. Number 1, 219. Number 2, 584. Number 5 should be 429. 430 would be fine. All right, that's all I remember off the top of my head. So what's the next one? 6 would be 2.04 atmospheres. 9 would be 2.02 decimeters cubed. 12 would be 609 Kelvin. Next. 15 would be 1.46. 726.2 mmHg. Number 5 says, what is the volume at STP? If you did 5 wrong, you probably mixed that up. Since it said, what is the volume at STP, your question mark has to stay with what is the volume. So if you put your question mark, it has to be with the STP. All right?
So we're figuring out the first volume, not the second?
Doesn't matter. It could just as easily be V2, P2, and T2, but the question mark has to stay with the STP. That 502 milliliters has to stay with the 96 kPa and the 29.7 degrees Celsius.
You sure about that?
Yes.
Kidding.
Did you notice I didn't reference any of those numbers on the worksheet? I've worked this question so many times over the years.
Stay right there.
Everybody does this wrong every year.
It's okay, sweetheart.
Okay? Now, the units have to match. So this can be changed to 101.325, or you can change that one into 0.96, 0.97, something like that. 0.94. It's close enough. All right. Change this into kelvins, which will be what? 302.7. All right. But the problem is people mess up where the question mark goes.
Yeah.
If you put the 502 with the 1 ATM and the 273, that's why you worked it
I
wrong.
had to read it about 3 different times.
Okay? That's the mistake.
Yeah. What's the answer again?
429.
Yeah, I had to reread the question options.
Okay. What's next? 12. All right. 12 says, odds are good. This one's probably a unit conversion. All right. So you've got volume 1 is 2.71 liters. And then it says 102 kPa. And then T1 is negative 18 degrees Celsius.
Wait, which question is it?
This is 12. And then you have 39, 10 milliliters. And then you have torr, so that's a pressure. And then you're looking for T2. All right. I'm going to cheat just a little bit. All right, so this will be 255 Kelvin. I did them in KPA. Can't make out what it is because I have a hole through it. I think it's 169. I changed that to KPA, so I have it in 169 KPA. You don't have to do it in KPA. You could have changed it to torr just as easily. Which would be 765 torr if you did it that way. If you changed it to ATMs, you'd have roughly 1.00 ATM. 1.67 ATM. If you did that, you'd have 3.91 liters. If you went to milliliters, you have, whoops, put it in right, stupid. All right, you'd have that. So,
Ms. Wall,
yep,
can you get 15 and 16?
in a minute.
Because I don't get them.
All right, so V1, P1 over T1 equals V2, P2 over T2. So now you just need to pick which units you chose on your paper. So if you chose volumes of liters, you got to make sure you pick both of them in liters or both of them in milliliters. If you chose ATMs, pick the two that are in ATMs, pick the two that are in torrs, or pick the two that are in KPAs. Okay, it depends on which units you chose. They just have to match. So 1, because I did liters, and then 169 because I chose KPA, and then over T2. Okay, so the units just have to match. Did everybody see how I picked liters and I picked KPAs? You just make sure your units match. So 2.71, 102, T2, 255, 3.91, 169, and then we're going to divide over here by 2.71 and 102.
Correct.
2.71 and 102. Okay? All right, number 15.
What was the answer for that?
The answer for 12 was, what did I say 12 was? 12 was 609. Yep. Number 15 says, what is the partial pressure of oxygen? All right, so if I said, what's the partial pressure, I had to tell you the total pressure, right? Now, Alicia, since I said, what is the partial pressure, I had to tell you the total pressure. Aren't you the one who just said what's 15 and 16? All right, so what's the total pressure in number 15? Since I said, what's the partial pressure?
367.
So 3.67 is the total pressure. All right, so that means I got some more partial pressures in here. So what are my partial pressures?
0.45,
Plus.
oh, sorry, 1.2,
Uh-huh.
and then 0.556.
And then
What are we trying to figure out then?
the partial pressure. You're finding the other P, just like in the opening.
Also, there's 4.
So there's 4. Yep, doing it next. Okay, so you're doing it. Add all those up and subtract.
I didn't know if that was like, they already gave us everything.
No, you're finding the partial pressure. All right, so number 16, this is like the last one we did yesterday that's collected over water. You see how it says in there, what's the partial pressure? And it says it's collected over water in the question. Okay, since it says collected over water, pressure total equals P gas plus P water. All right, so this one, we're getting off that chart. Okay, we're going to have to look that one up. One of these two is given in question. One of these two you're finding. This will be partial pressure. This is total pressure.
And the water's on the chart.
Water's on the chart. So what does it say? What is the partial pressure? So since the question says what is the partial pressure, which one are we finding? P total or P gas? So we're looking for P gas. So that means the number they gave us has to be P total. So the one they gave us is 750. So that means the 750 goes there. And this one we find on the chart. So on the chart, we look up 25 and mmHg. So 25 and mmHg is what number? 25 and mmHg is 23.8. We okay with 23.8? Okay. So subtract 23.8. Subtract 23.8. And that's how you get the answer.
I just got it out.
The two backwards.
Like I got the water chart. I forgot how to read it.
Okay.
So
So
you look up the temperature.
you look up the temperature and you make sure you're in the mmHg column because this number was mmHg. You don't read the kPa column because I didn't give you the number in kPa. Does that make sense?
That's what I.
Okay.
Okay.
Anything else?
No.
Huh? 9 says find the volume. Okay. So what is the volume? All right. And then it says decimeters cubed. So 10 decimeters cubed is a what? It's a decimeter cubed. What's that tell you it is? That's the volume. All right. And then it says at STP. So what's that tell us? Okay, so we got a temperature and we got a pressure. And if we keep reading, it says at constant temperature, and then it says 500 kPa. So what's kPa?
Pressure.
There's a pressure. Okay, so we've got a V, a V, a P, and a P, and it said constant temperature. Now, they told us the temperature standard, but they also said it's constant. So do I need to use it? I wouldn't use it. I mean, you can plug it in if you want, but on the bottom, you're going to have 273 and 273 if they say it's constant. Do we need to use that? I'd leave it out. I'd use V1 P1 equals V2 P2. All right. So what's V1 and P1 and V2 and P2? Well, what has to stay together? See how it said 10 decimeters at STP? That 10 decimeters has to stay with standard pressure. So 1 ATM. And then the find the volume has to be the 500 kPa. Now, do these match? Mm-hmm. So my V1 is 10. My P1 is 101.325. My V2, I don't know. My P2 is 500. Divide both sides by 500. Anything else?
No. Please.
Now, you may have your stapled orange chart because it has your conversion numbers on it and it has your formulas on it.
We just watch Bill Nye instead.
Nope.
No, we
Can we
can
have
have
we can have the white sheet or something?
Yes.
You don't need it.
I was gonna have homework. Do we need this?
That's why I told you you only need your orange sheet.
So we don't need the little thingy I cut out nice and pretty.
You do not need the little thing cut out nice and pretty.
Look at this.
It is fabulous and you did a great job, but you don't need it.
You have a hairband? No.
She said.
What for?
You have a rubber band?
That I have over there.
My hair should be.
Ms. Wall,
Yes.
I need Dylan Harrison to come to guide us.
Okay.
Whoa, come have an Oreo. No, but Annabelle.
Because you forgot the decimal between 96 and 0.
This one, so we don't miss out.
Ah. Annabelle.
You can't find one in there, look in the drawer behind you, there's a box in there. Alright, you did it most, 30 minutes.
No.
It's only 5 questions.
Wow.
You do not need more than 30 minutes.
That's down.
I do.
Look, Diane.
Stop.
It's not even like, this one's.
And you heard that usually.
Perhaps later you can teach her how to do that so she doesn't look ridiculous.
Is this right?
Oh my God.
You look absolutely.
She looks like one of those Ewok kind of characters in Star Wars.
Look.
Alright, everybody should have a paper.
No.
Make sure you show me work. They are 20 points apiece. They do have partial credit. And I would like to give partial credit if you make some dumb error.
We need
So show me work. I said, so there's no periodic table. There's no grams or moles on it.
It's the 18.
I was just wondering.
Just get the record.
Again, she doesn't listen to the instructions.
I was doing an error.
Yes, you were. It looks magnificent.
Look at this.
No.
You said significant digits don't count.
As long as you're within a couple, it's fine. Now, if you write down every number on that calculator, I'm taking off for significant digits.
Well, when you're putting C, you mean like Celsius, right?
No, she's that.
Well, it doesn't have the degrees thing.
Yes, it's Celsius. What?
Thank you.
Yes, I told you I did that after the quiz.
Do what?
Get out the reference table. Are those? What are those? What is that? Yeah, I know. What is that? Are they the same units is what I'm asking?
I don't know. Yes.
So, you might not be able to convert those two things to each other. You have a what and a what? No.
No?
No. But the two units, they're not the same.
Yeah. Okay.
Yeah, I'm not posting lesson plans. Correct. What? Hey, that's hit you with one. answer key has done all the units. So you choose.
Bless you.
I don't know. I know. Why are you sitting at the same counter as I am?
Just not myself.
Nope.
You didn't tell us no?
Yeah.
Dude, that's an understanding we have at this point. Every time you take something that's graded, one of you two needs to move it.
Well, I mean, it's not like we cheated because she obviously struggling.
Right.
I'm down already.
Hey, Bowers. She's the only reason we can do to come in from fire department. I was gonna thank her.
Yeah, the other day.
One of Miss Richard's students, her lead has a drawing.
Have. Where was it? Oh, in class? Just chilling?
She got it. You don't have to still working. Alright. You guys have about, it's like 7 minutes.
I'm really just hoping for a partial credit on these two.
There is partial credit, but you gotta have something that's partially right.
I think.
Everything's worth 20 points, yes.
And there is partial credit.
Yes, there's partial credit.
So like, you like, set it up right?
Theoretically, yes.
Okay. If we submit partial credit, if we don't convert, right?
If everything else is right.
Even if like the numbers are wrong, but like you're doing it right all the time.
Yeah. Who's still working now?
Annabelle. Mama's home.
All right, well, Annabelle's finishing fresh purpose of the front. See, it's gonna take a moment.
Can we not plan anything too hard today? Because like, we're gonna be out.
Well, it doesn't work that way.
She got it.
Ready to go.
I'm done. No. Oh. There you go.
Thank you.
Show it a left.
All right, find your notes.
No.
You got stuff to do.
No, let's watch a chemistry movie.
No,
Let's have a party.
Yeah.
never gonna happen.
What movies involve chemistry?
Never.
I'm not.
Well, I could be hit by a bus and you could have a sub, then you could have a party.
No, we don't want you to get hit by a bus. Well, you know,
And you got no
can't
party.
drive. Everybody drives in front of you.
Now, my best guess right now is the gas law test will be the Friday that we come back. Just tell me. Alright, so we're gonna talk about Avogadro's principle and the ideal gas law today. Well, we're gonna use this number here in just a minute. Come on, hurry up.
Yeah, how many? I was gonna give it a call right here.
And odds are good these will not go in the computer until Monday after break.
Yay! I want to know.
I wanna know what I thought.
Unfortunately, I'm teaching pretty much the entire time, third and fourth period, so I will not have a
I know I
chance to
got 100. I'm smart.
do that third
If
period.
y'all think we are bad, come in here during our fourth period.
I feel
I
terrible
might,
for this
you know.
moment.
Oh, this is
It's-
good. You can get here fourth period last semester.
It was
They're delightful.
Benjamin, Denori, and they go at it the whole time. Like
Oh, you didn't even get the joy of JD being in here.
Benjamin sits right here, and Denori just rolls around on a rolling chair, and like Benjamin would say something.
He's usually over
Say
there in the
something one
corner.
more time, and smacks him in the face. He talks so fast. It is,
Denori is like that.
it is
Normally,
hilarious.
Denori's in the corner by himself.
Oh, why are you so?
All right, so Avogadro's principle.
What'd you do for Biscuitville?
Nothing.
Ham and egg biscuit. I splurged today. Got a Pepsi. I don't know.
Ham and egg. Disgusting. Right.
All right.
You try to chicken biscuit, but you going honey?
No.
Now,
Racist.
Avogadro's principle states that volumes of gases,
nowhere near ready.
all right, at the same temperature and pressure will have equal numbers of molecules.
Is he right?
Yeah, he's right. I'm not teaching you stuff that's wrong. I'm not even teaching
First of all, you
anything.
did.
Yes, everything we're doing is on the exam. The only thing I taught that's not on the exam was that itty bitty stuff about collected over water. Everything else that we've done will be on the exam.
Wait, what did you say about
Whereas, let me say this, it's fair game for the exam. There are only 45 questions on the test. That's it. So half of the stuff I've taught will probably not be on the exam because there are only how many questions? 45. What they're going to pick out of the stuff that is fair game for the exam, I have no idea. Okay? They say teach all of this, and they will pick 45 questions. I just have no idea what.
But what if, like, you don't finish teaching? Like,
Yeah.
are
Do
you
the best you
serious?
can.
Are you serious?
We stand a much better chance this semester because there's more days in this semester than in the fall.
This fall?
Now, look, here you can have water. Everybody got it?
No.
We can talk about it? Now, what this says is, suppose that you have because I like pictures. You can probably guess that my learning style is visual. Suppose that you have two volumes that are 10 liters. Okay? They're both 10 liters. According to Avogadro, if their volumes are the same, and you know that they have the same, okay, I didn't say standard, I just said same, temperature and pressure, what do we know about the molecules inside of the box? They'll be equal. Okay? We know that their molecules are equal. We may not know what they are. We just know they're equal. Okay? We can make that assumption. Okay? If we know the volumes are equal, let's just say they're both 10 liters. And we know they have the same temperature and pressure. All right, for example, this room has the same temperature and pressure. Then we would be able to assume, what about the number of molecules inside of the gas container? They will be equal. Well, theoretically, I suppose. Does everybody have it?
No.
If they have the same temperature and pressure, they will have equal numbers of molecules.
It's like, let's say there's another class like your class will be like, oh, you know, like theoretically.
Theoretically,
It can hold the same amount.
it can hold the same amount of people if it had the same size. All right, everybody there?
No.
All right, Abafushus, come on.
Oh.
How do you know that?
Shelby talks about me.
Only she pronounced it as a French-sounding word, so it sounds a little better than Abafushus.
How does she pronounce it?
Abafushes.
Oh my god.
Next page.
Huh?
Next page. Let me do it.
All right. Now, since we're talking about Avogadro,
I thought she was about to say Abafushas.
oh,
Let's change Avogadros to Abafushas.
no.
I want you to discover something and then
Anyway, you're not that smart.
I'm gonna come up with something. Y'all gonna be shook.
We would be shook.
She gonna come up with a new way to get in jail.
All right. So let's say for a second,
Jamal cannot get this square right.
let's say,
Well, you can't draw.
since we're talking about Avogadro, that he put 1 mole of molecules in here. All right. Now, since we're talking about 1 mole of molecules, how many molecules is that?
6.022 times 10 to the 2.
What?
Just checking.
I knew it, but like.
You just couldn't get it out.
No, she just said it really fast.
Right.
Like, I know that, but she
Okay.
said it like she has been studying that her whole life.
Alright. So, and again, it's at the same temperature and pressure.
As well,
What?
do you ever like use two colors at the same time and like think of something like when I
So
see
you better get to a good point because that's just obvious.
when I see green and purple, I think of the Hulk.
Hush. Now,
When I see red and blue,
No.
America.
so if we go backwards and we say we have the same number of molecules, according to Avogadro, what do we know about the volumes?
They're the same.
That's right. So the volumes must be equal.
We gotta remember this number too.
It's on the orange reference sheet. All right. Avogadro found the volume of 1 mole. All right. 1 mole equals 22.4 liters. Now, you had to put a stipulation on there. Not only does it have to be at the same temperature and pressure, what temperature and pressure did he have to use? That's right. You have to use standard temperature and pressure. Now,
What?
you do not have to remember the number because where did I just tell you you could find it? It does have a name, and it's also on the reference table. It's called standard molar volume.
Yes, sir.
What
Okay.
is it at?
It's called standard molar volume.
Where's it at?
It's
It's on the top. Right there, there's gas wall things.
22.4.
One volume of 1 mole of any gas.
That's what that is. Volume of 1 mole.
Can I duct tape this?
Do not use the duct tape from the tech people. They're still working on that desktop computer. It's been doing updates for 3 days.
I just want to like
Hold up now.
duct tape me to a
So they came
stool.
back.
They keep coming back to check on it and see if it's doing updates.
It's still updated.
It's still updating. It was as of yesterday afternoon, 4th period.
What is the update?
The operating system and it had over 200 updates to do.
Yikes.
Plenty
All right.
of time.
So here's a problem that we would do with Avogadro's principle.
Ah!
I'll write it down.
Why am I sore? What did I do? I'm confused.
You
Oh.
You have to know. Well, that's a lot to be right.
Okay, don't write it.
I'm not. I just write the numbers down.
That's why you don't
I
understand.
hate to sound like Joyce and Cecilia over here from yesterday and Nakaya today, but this might be part of your problem.
No, my problem is I can never remember. Like I couldn't remember today what you do if you only have 2 numbers and not 3. Then I could. For the
We
first
worked multiple questions exactly like that today. I'm pretty sure we worked almost every question on the quiz today through the homework and the opening.
Yeah.
no, you did, and I forgot I did the opening, and I could not remember it. I swear I need to be diagnosed with short-term memory loss.
I don't know what to tell you.
I can't remember it. Well, we just learned it, and Miss Ball knows that because when I would take my makeup quizzes, we review, and then I'd get those questions wrong. So bad.
You got short time.
Like she literally gave like on one of the review things, it was the same question as the quiz, and I couldn't remember what the answer was, and I got that one wrong. Crap.
I don't have to make it. And well, you know what might work is if you do the homework and that's my what if you don't?
Mm.
What color should she
I've often suspected that, but don't want to out and out accuse anybody.
Well, why have we had many quizzes this semester?
Because of the way the information is challenged, it's harder to.
Yeah, I swear we had one like every day last semester.
It was easier to do it last semester. You'll have more in a few weeks. You'll only have one more problem before the test. All right, so if you look at this, first of all, what makes this one different from the ones you just took on today's test? Because remember, next Friday, or today's quiz, next Friday, these will all be mixed up. And some of you, and I'm not picking on Annabelle, but for those of you who struggle with how do you tell the difference? How do you tell the difference? Because you know when you ask me on the test, I'm going to be like,
Well, there's volume,
I don't remember.
temperature.
Molecule.
it has molecules in it.
Yeah.
Okay? Did anything on today's quiz have molecules?
No.
No. Okay, there's nothing had molecules in it. Secondly, what does it tell you about temperature and pressure? They're constants.
It's the
They're
same. Yeah,
So-
it's the same.
Because it says they're the same, does that mean you can plug in a temperature and a pressure? No, they didn't give you a temperature or pressure. There's no temperature or pressure here.
Wait,
So you cannot plug in a temperature and pressure. You can't use a P1, V1, T1 type formula because it's not given to you.
I know, but.
Okay?
so
You cannot assume 273 and 1 ATM.
how are you supposed to do it if it has
Okay?
like there's the same?
There's no temperature and pressure. It's not. It's no.
I was like, what is that?
All right.
Like, no.
You have molecules.
But it's the same.
So the only thing we've learned about that has molecules and no temperature and pressure is Avogadro's principle. Okay? So, what can you tell me about what you have? You have 5
and five.
liters.
Which I'm confused about.
And you have 5 liters. The volumes are the same. So if the volumes are the same, what does that tell you about the molecules?
Molecules will be two.
The molecules will be equal. So the answer to the question is 5.23 times 10 to the 25th molecules.
Okay, that's what I thought.
That's the answer.
Where did that come from? Oh,
Avogadro's principle says if the volumes are equal, what do you know about the number of molecules?
And they already gave you that. and
They're
it's the same
equal.
amount.
Because the volumes are the same. Can we agree the volumes are equal?
Yes.
All right. It says in the question, how many molecules would there be? Well, how many molecules did they give you?
None.
Now, if the volumes are the same, what do you know about the number of molecules?
The molecules will be two.
They'll be the same also.
I'm confused.
There's no math to be done.
I'm like, hey, I looked down and I looked up. It was like,
Avogadro's principle says if the volumes are equal, the molecules are what?
the same.
Equal. They're the same. There's no math to be done. If you know the volumes are equal, the molecules have to be what they gave you.
All right, question.
All right. What's the question?
What if the volumes aren't equal?
Okay, that's where I was going. Let's say I am tricky. Okay, because Rosanna went there. Let's say on the test, I do this. Okay?
Oh, what's your purpose?
Okay? Say I'm tricky.
Times that by two because that's what you do with volumes.
Exactly.
Okay.
Wait.
You got one thing right.
Annabelle had a moment. We need to applaud. All right? So the volumes were double. So what would you do to the molecules?
Double.
Multiply by 2. That's all there is to it.
That's
Okay.
all Avogadro's principle is.
That's it.
Wow. Quiz.
Now.
I said no, quiz me on
All right.
Now. Give me the quiz now.
Now, if I had to guess which of these gas laws that we're doing on the exam, if I had to pick, this is the one that I would tell you that you will see on the exam.
And what if it's not?
I'm just telling you I'd have to guess. This is what I would guess.
What is that?
Now, it will either be the short problem or it will be with stoichiometry. If I had to guess, it will be with stoichiometry, no. Okay? Now, PV equals nRT. It's called the ideal gas law.
Hold on.
It's
real
not
quick.
hard.
I need to just write this in a bright color that literally,
Now,
if volumes are the same, the molecules are too. Do the last.
R is called the ideal gas constant.
You made that way more complicated than it was.
Now, there are 3 R's on your reference table. I could teach you to change R based on the units in the question, which is the way I choose not to teach it. Some teachers will teach it that way. I'm not one of them, okay?
Wait, I have another
So,
question.
this is the way I'm going to choose to teach it. The ideal gas constant that we will use is this one. Now, its units are liters times atmospheres over moles times Kelvin. Now, it doesn't matter which R you choose. Every R has 4 units.
What is an R?
R is a constant. It's the number we will plug in for R every time we use this formula.
Wait,
Now,
Miss Wall.
the catch is, regardless of which R you pick, you have to use the correct units. Rather than you having to change the units depending on the R you pick, I'm only going to teach you to use one R, so we're always changing to the same units.
As well.
Okay? For those of you who are math challenged or science challenged, it works better that way. All right? What?
Okay, so hold on. I gotta go back because I just wrote something. And stop writing it. I gotta show you.
Why is there an A in the middle of my formula?
I don't know. I didn't do that. Say there's like, say that second one's like a 12 or something.
I wouldn't do that. I will
So the
only
exam
double it.
would- The exam would, could you triple it?
No, yes, I could triple it. You
But you'd
multiply
only do it
by
in
3.
you'd only do it in like
And
a
even
factor.
amount. Yes.
Okay. Who put an A?
You did.
I did it.
Now, what unit is pressure in this R? That means that every time we use this formula, pressure has to be in atmospheres. What is volume in? People, we're not on spring break yet. All right, volume has to be in liters. And is a new variable. And is moles.
It's not new.
It is in the sense we haven't used the letter N in a formula.
T is K.
And T is kelvins. Now, this is different from the quiz today in that when you used volume, what was the only catch to the volumes? They had to match. Did it matter if it was liters or milliliters? No. When you use this formula, Caleb, the volume must be in what unit? I'm not out the window. All right? Spring break is coming. We're just not there yet. All right? Volume has to be in what unit? It has to be in liters. Okay? Pressure has to be in what? ATM. Temperature always has to be in Kelvin, so it doesn't matter. And then N has to be in moles.
So what is that little thing you got going on over there? L times ATM?
That's the unit on this. It dictates the units for those 4.
So like, whenever so say we get the answer.
What if it's like 1.1 L times A? Is that what it is?
Yeah, it's
It's-
like,
That is R. That's the number we use.
so I'm confused.
All right, write that down.
All right.
Just
write it down.
No good solid water. Water. I gotta write this down.
Water. Yes, bring some water. I don't want you to be parched over there.
She said a side of water.
Do you have any dog biscuits over there?
Well, do you have anything to eat on the Starbucks?
I'm starving.
You're starving.
Yes.
You know, even Ms. Rector called them dog biscuits yesterday. She said, what are those things you had in your lunchbox? Is it cardboard? Oh, no. Dog biscuits. That's what they were.
Do you have any?
Yes,
Can
why?
I have some?
No.
Why?
They're my lunch.
I don't have a lunch.
Get some out of the cafeteria.
Yes, please.
I got some peas.
Ma'am, you can enjoy those peas, but I'll enjoy the dog biscuits. You need that.
My family enjoyed the photo of you begging for a dog biscuit on the floor, by the way.
Oh, yay.
I was there laughing. I would have posted it.
We all want to go home. We're a few hours away.
What time is it? Spring break time. It's talking kids. Time for our life. School's out. Scream, shout. Finally, spring break's here. Good. Stretch it out.
Get my boys with a bell.
I mean, he does.
Shelby hasn't responded and I'm hurting.
Oh my God.
All right.
Small.
All right. So what do we know? What are we looking for? Dude, you're going to have homework over break at this rate.
Shut shit up.
Right.
Because everything we don't do today has to go into Monday, which means you have more to do Monday. Because on Tuesday, we will be on stoichiometry, whether you understand or not.
Why do that?
I'm okay with no homework over the break. I'm not planning on doing any work either. But on Tuesday, we will be on stoichiometry. All right, so what are we solving for?
Solving pressure.
Okay. What is 15.2 grams?
That is the R.
It's got to go for N because what could grams be changed into? It can be changed to moles. All right, what's 150 milliliters?
Volume.
Okay. And what is 25 degrees Celsius?
Temperature.
So what's
Now,
R?
what's R?
0.8.
What did we just say R was called again? The ideal gas constant. What does the word constant mean? It stays the same. It never changes.
So whenever there's
You're
R,
going to put that number there every single time. It's on the orange chart. You look it up. That fancy unit that's at the end dictates the unit that all four of these have to be in. Now, that means volume has to be changed to what unit? It has to be changed to liters. We cannot leave it in milliliters. Every time you forget, it's an automatic deduction. On the test, it's a -3. If it's a 6-point question, you just lost 3 points.
Yikes.
If it's a 7-point question, you lost 3 points. You have got to learn to change it to liters. All right?
Miss Law is the.
All right? Grams. Grams has to be in what? Moles. All right, so grams on the bottom, moles on the top. What compound did I give you up there? Do we know anything special about nitrogen? It's diatomic. So 14 times 2 is 28. So what's 15.2 divided by 28? It's 0.542.
Yeah,
Well, that'll be a problem. All right. And 28 has to be changed to Kelvin, so that'd be what, 298?
Yeah.
And K. Now,
Wait, what is?
did I say 28? 25. All right, so because I'm using R, what do I know pressure's going to turn out to be in? ATM.
Oh, so it's not going to be in that liters over.
No, that's just the unit that R is. That tells us what those things are going to be in or should be in. Okay? Now, all we have left to do is what? All right, so plugging in and getting an answer. Everybody got what they need up there? PV equals NR and T. All right, I like this equation for most people because I think it's easy to plug in. Pressure we don't know. Volume was 0.15. Moles were 0.542. R is 0.0821. And temperature is 298. So to solve for P, all we have to do is divide by 0.15. Divide here by 0.15. And we have pressure. So 0.542 times 0.0821 times 298 divide by 0.15. 88.4.
ATM.
And we write ATM on the end.
This is beyond me.
I like this.
So like, how do you know, like, when to use this and when to use other?
You have to know that. Now, so when you look at the questions, all right, does everybody have what they need?
Yes.
So if I go back for a second, I'll scroll up to the top.
Right.
All right, how are we going to know?
Yeah.
When you look at this, first of all, what is this?
Grams.
Did you have any questions today, like at P1, V1 over T1 that had a grams?
No.
Secondly, how many pressures are given in this question?
None.
It asks for a pressure. Is there another one given? So could you use a P1 and a P2 if it asks for a pressure and there's no P2?
No.
No. So that's going to help eliminate those types of equations. Does that make sense?
Yes.
Okay.
So look for grams.
All right, write that one down and we're going to solve it.
This one does not have grams, so have what mass? No. Oh,
Ms. Wall, does your daughter ever ask you for help on chemistry?
She did, but it was very rare.
Does it, like,
bro, I'd make you do my homework.
no, I didn't bring my nose kit.
Oh yeah, she gave a ton. If y'all ever think I give a lot of homework, don't lie. I was appalled at the amount of homework it was. I mean, when they had to balance equations, she would bring homework. She'd have 50, 60 balancing equations. When they did naming, it would be 100 homework questions. I mean, it was,
They had
it
like
was
a
insanity.
one of our girls, he had a 6-page lab report about some lab he had to do.
Oh yeah,
That
they
was
were,
like removing the color off of some M&M.
oh yeah, they're long.
Yeah, I would imagine.
Yeah.
Right. I would fail that class just because I have missing assignments.
Oh, you would have done horrible.
Okay.
All right, so what are we solving for? If it says what is the mass?
You're solving
All right,
for
I heard it at the back.
And
You're solving for N because mass is what? It's moles. We can get mass from moles. So we got to have everything else. All right, so what is the 300 milliliters?
Volume.
That's volume. All right, what is the 27C? And what is the 356.8 kPa? All right, and what do we know about R?
0.0821.
All right, so am I in the right units? Can I plug and chug? No, I'm not.
Oh,
All right, none of them are right. So that means we got to change a ball.
this one first.
27 plus 273 is 300K. All right. Milliliters to liters, 1,000.
I can see after that, I didn't even think it was right.
0.3
I
liters.
hate myself. That's what I was gonna do on the quiz, and I didn't do that.
Okay. KPA to ATMs. 101.325 should be 3.56 ATM. We're pretty close. Are we okay with the unit converting?
Chug and plug, chug and plug, chug, chug, chug.
So PV equals NR and T.
Huh?
Pressure is 3.56. Volume is 0.3. And
chug, chug.
all right, so how do we get N? What do I divide by? By what?
R and
I'd multiply 0.821 first.
All right, I'm not doing that. I will divide and then I will do it. All right, so
Crazy.
0.0821 and 300. So N equals, you can do it on your calculator. I'm just not doing it on the board. I got 0.0433. Did anybody else get that? All right, now, this is the hard part for most people. This is where we go wrong. What is N?
Grams. So you gotta convert
That's
to
where we
moles.
go wrong. People go, oh, that's grams. It's what? N is moles.
Ah,
Okay? So you got to remember that's moles. So now you have to take your 0.0433 moles and change moles to grams because I asked for mass, which we all know how to do. We've been doing it since week 3. Okay? So what goes beside moles?
One.
And then you go back up and find whatever compound I gave you. Should be rounded to 71, but if you put 70, I would not take off. All right, so multiply 71.
Oopsie.
I asked for mass. Anytime I ask for mass in a question, mass is always grams. Questions?
No.
I do, and I'll be glad to give it to you if you want it.
No, I don't want it.
Okay? That way, those of you who wish to practice can. You have 2 more formulas that go with this on work time to practice with it in class. It may not be enough for all of you. For some of you, it will be plenty. Okay? I'll tell you which ones you can do. Thank you.
Yeah.
Oh, I'm going back then.
I got it.
What is this? Just put it in your notebook. Now, for those of you who are struggling or know you're going to struggle on the gas laws, you need to be able to work anything in 4 to 7 and 12 to 15 using that law. Okay? Avogadro's principle is number 1.
You said 1 to 7 and what?
Avogadro's principle is number 1. 4 to 7 and 12 to 15. Anything in that range would be the ideal gas law. Okay? If you do anything, I will be glad to show you the answer. None of that is required homework.
I'm doing it. Oh, yeah.
Always reiterate.
Is she taking this?
I'm not.